All right, here we go. Question number 36 from our Calculus 1, homework number 1 in WebAssign. It says find the limit if it exists. We have the limit as x approaches -2 of the function 2 minus absolute value of x, all divided by 2 plus x. And I must say the easiest way to evaluate this limit is going to be with a graph. So looking at the graph in Desmos, we're concerned with as x approaches -2. Coming in from the left, we can see that the function has a value of 1, and that actually doesn't change. Coming in from the right, we can also see as we approach -2, we have a function value of 1. Since we approach 1 from the left and the right, then the limit of this function, and you can see I've input it correctly here, the limit of this function as x approaches -2 is 1. And again, I want to point out that at -2, the function is actually undefined. And remember, the limit doesn't care what's happening at the value. It only cares what is happening as you get close to the value. So back to our WebAssign, we can fill in our answer of 1. And you may be thinking, well, wait, is that the only way to get that answer? Because I don't have access to Desmos. Well, guess what? There is another way. So what we can do in our scratch work is we can look at values of x that approach -2 from the left and from the right. And so what we're going to do is we're going to complete these tables. The first table shows x approaching -2 from the right, and the second table shows x approaching -2 from the left. And we're going to do repeated plug and play using our calculator to calculate these values. All right, here we go. First, we've got 2 minus the absolute value of, and if you're wondering how did I get the absolute value on my Casio, that is shift and open parenthesis. It says ABS in yellow. That gets us the absolute value. We're concerned first with -1.9, and in the denominator we have 2 plus -1.9. And yes, you can put plus a negative because I'm using the negative button, not the subtraction key. Oh, and look what we get. We get a value of 1, and I bet the other 2 values that we get here are also going to be 1. Remember when we looked at the graph, it was a constant function, at least around -2, and so all the y values should be the same. Here, let's go back and edit. Now -1.99. Look at that, and we get a value of 1. And if I rinse and repeat and make that 999, yeah, we can see that we're going to get 1 again. All right, so now to complete the second table, and some of you may be thinking, why waste your time? That's just going to be 1 as well, but I want to prove it. So in the denominator, that would be 2 plus -2.1. And then in the numerator, we're going to delete and make that -2.1. Look at that. And we get 1 again. And so to not waste your time, we can edit those values to -2.01, -2.001. We're going to get 1. And so what we can see here, again, approaching from the left, we're getting, well, we're actually at 1, but we're getting close to 1. And approaching from the right, we're getting close to 1. Therefore, the limit is 1. So let's click submit and see how we did. And it appears that we got the green check of success. So that's going to do it for this problem. If you have any questions about anything covered in this video, please feel free to leave those in the comment section below, or you can text me, and thanks for watching.